Hey, Chris Matthew here from Compute Inc. We've had a lot of people asking about our decentralized distributed mesh computing technology, Lattice in particular. So I thought I'd spend a little bit of time explaining what that is. Rather than using a traditional blockchain approach, we wanted to build something that had extremely high throughput. Today, thousands of transactions per second, hopefully tomorrow, millions of transactions per second. We didn't want to deal with wasted proof of work computations. We wanted every compute instruction to be meaningful. And we didn't want each node to retain a ledger, like a typical blockchain type solution does. We wanted to build what we call a mesh computer, where all of these disparate machines, everything basically being able to swarm, discover, connect with one another, communicate peer-to-peer, and compute together as a single supercomputer, if you will, with millions of transactions per second in massively parallel applications as well as serial machine learning applications. So what we decided to build, since we couldn't find anything else out there to do this, we built a DAG-based transaction ledger, for lack of a better word. DAG is a directed acyclic graph. And then on top of that, so that manages all the transactions. So tasks get submitted from any node in the network requesting computations. Even tasks can create other tasks. We talk about organic mesh networking of computing nodes, but also organic computations of nodes, where the artificial intelligence algorithms can run as close as possible to the data source. So Lattice is this decentralized queuing system built on top of our DAG. So look at our DAG as basically tasks or computational transactions series, whether they're sequential or massively parallel. It's all of the tasks and references of input-output files, just all IPFS hashes and manifests associated with each task. When you look at Lattice, Lattice is the decentralized queuing technology on top of our DAG that receives these tasks and manifests, and then it has all the profile information about the task, as well as all the nodes meshing together to perform the computation. So each node is reporting to Lattice its MIPS capabilities, machine instructions per second, its current machine utilization, CPU, GPU utilization counts, its operating system, its location, whether or not it's wired or wireless. I mean, all of these meta properties about the node. Lattice organizes all of the work into multiple queues. What's in queue to be worked, what's in process, and then what's completed. And then it's managing with the DAG all of the I/O, as well as the logging, etc., so that you can crawl the DAG and reassemble all of these computational tasks. So when workers have availability, or machines on the network that want to do computations on behalf of the private mesh computer, they basically cherry pick computes off of Lattice that says, hey, I'm in Asia Pacific, for instance, I'm in this particular location, I've got GPUs, I'm only 50% idle, and maybe my MIPS are maybe 1,000 machine instructions per second. So these machines, and time to live, that's also another important piece. So they say, hey, I can accomplish that computation, I think, in the time to live. So Lattice tracks that machine 123 picked up that job, and then if the time to live expires and Lattice has not heard back from that worker, it can pull that computation back and get it back in the right queue, so that the next best machine picks up that computation to work. So what we've built, I don't consider blockchain-esque in any way. It is truly decentralized, distributed, high-performance computing, allowing, tailor-made for artificial intelligence, where the computes are happening as close to the data source as possible, or an entire organization's idle computing capacity can be harnessed or activated, if you will, to perform like a single supercomputer within an organization or on the edge network as well. So hopefully that explains a little bit more. More videos to come.